So here's a summary of what we'll be covering in this project today. We'll start with a brief introduction to the inverse design method. Then we'll be looking at how the mainline design of a Sirocco type CPU cooling fan stage can be performed. Then we'll see how the impeller wheel can be designed using the 3D inverse design approach. We'll also briefly look at the design of the volute, and then we'll evaluate the aerodynamic performance of the baseline fan based on a CFD analysis. And then we'll see how the performance of this redesigned fan can be enhanced through the use of automatic optimization with inverse design. And finally, we'll wrap up with some concluding remarks. So let's start with an introduction to the idea behind the inverse design approach, which we use throughout this presentation. And as you can see in this workflow, these inputs that are used by the inverse design method are used to give us the final blade design. So apart from some basic parameters, these blade loading inputs are flow related. And so once you have a good understanding of your flow issue, whether it's tip leakage or profile loss or flow separation that you are dealing with, it's possible to come up with guidelines on the optimum blade loading to tackle each of these issues. And actually this know-how has generality, which makes it suitable for all your CPU cooling fan applications. And so what's interesting then is that you only need to rely on your knowledge of flow physics, and then this method works for you regardless of your fan size or which speed number regime it falls under. So this makes the entire process very intuitive and removes any empiricism that's commonly seen in conventional design methods. So a little bit of context for the present work. So while CPUs or central processing units are commonly used for highly demanding tasks such as rendering computer graphics for video games, machine learning and cryptocurrency mining, but with great power comes the need for effective cooling, and so CPU cooling is a critical aspect that directly impacts your system's performance and longevity. And here the goal is to maintain the optimal operating temperatures to prevent overheating, which can otherwise lead to performance throttling, instability, and even permanent damage to your CPU. And while Sirocco type cooling fans have been identified to be very suitable for this, they come with their unique design challenges. And a big reason for this is the extreme compactness required, which leads to very small, highly loaded blades with relatively large tip gaps. Now let's look at the design of fans in a bit more detail, and this chart here provides the relationship between the speed and diameter coefficients as experimentally found by Cordier, and is called the Cordier line in the literature. And so across the speed number range, fans are subject to various flow phenomena and loss mechanisms which are dominant in that particular range. So for example, incidence losses and flow separation usually take priority when it comes to CPU fans, which is the topic of this study. So the question then is whether it's possible to come up with a set of optimum design guidelines based on these fluid dynamic considerations of reducing the dominant flow losses for your CPU fan. And this is actually what we aim to explore through this work.